All right, welcome to this React Performance Masterclass. You know that feeling, right? That sinking feeling when your app, which used to be so snappy, just starts to lag? If that sounds familiar, you are absolutely in the right place. We're going to break down the usual suspects and give you the tools to make your app fly again. So let's dive right in. So, does this hit close to home? Your app was just blazing fast when you first launched it. But now? Well, it's not so much. You're starting to see that UI jank, those slow interactions, and just that dreaded lag. Look, it's a super common story, but the good news is we're about to write the brand new, much faster chapter for your app. And I want to be clear, this isn't just a feeling. It is a measurable, real-world problem. Get this. Poor render performance can bloat your app's scripting time by a staggering 30 to 60%. That's how much longer the browser has to spend running your JavaScript. It's just a massive, tangible hit to your app's speed. And this isn't just about some numbers on a developer dashboard. We're talking about real-world impact. We're talking hundreds of milliseconds lost during those critical moments when a user is trying to do something. And that directly tanks user satisfaction and can even mess with your app's SEO. Yeah, it's that serious. Okay, so to fix this thing, we've got to go right to the source. The root cause of most React performance issues isn't some super complex algorithm. Nope, it's something way more fundamental, the unnecessary re-render. We've got to understand the why before we get to the how. So believe it or not, every single re-render in your entire application starts from one of just 4 places. That's it. It's either a state change from useState or useReducer, a parent component re-rendering, a context value changing, or the dependencies of a hook changing. If you can understand these 4 triggers, you're on your way to taming them. Okay, listen up, because this right here is one of the biggest, most common misconceptions in all of React. A lot of us think a component only re-renders if its props change. That is just plain false. By default, if a parent component re-renders, all of its children re-render, period, full stop. It doesn't matter one bit if their props changed. This is that render cascade we have to get under control. So the big question is, how do we tame this wild cascade? Well, we have a pretty powerful toolkit. I like to think of these tools as a spectrum. You've got your chainsaw for the big jobs, and you've got your scalpel for that fine surgical precision. First up, let's grab the chainsaw. This is React.memo. Now, it's called a higher-order component, which is really just a fancy way of saying it's a function that wraps your component. And what it does is simple. If the props going into your component haven't changed, React.memo basically puts up a big stop sign and tells React, hey, stop the render cascade right here. It can save an entire branch of your component tree from needlessly re-rendering. But you don't use a chainsaw to cut a twig, right? Same idea here. React.memo is for pure components. The ones that always give you the same output for the same props, and especially ones that are genuinely expensive to render. If you try to wrap every tiny, simple component, you can actually add more overhead than you save. So use it wisely. And here is a classic trap. This is the thing that makes React.memo completely useless. See that inline arrow function? Every time the parent renders, that creates a brand new function in memory. As far as React.memo is concerned, the on-click prop did change, so boom, it re-renders. This is exactly what useCallback is for. It gives you the same function reference every time, so React.memo can do its job properly. Okay, so now let's talk about useMemo. This is different. While React.memo saves the entire component's output, useMemo is for saving the result of one specific expensive calculation inside your component. Think of it like caching a value. It runs the calculation once, saves the result, and only reruns it if one of its dependencies changes. So let's bring that analogy full circle. React.memo is your chainsaw. It's for chopping off entire rendering branches. But useMemo and useCallback, these are your scalpels. You use them with precision for very specific problems, like a function that needs to be stable or a calculation that's super heavy. You absolutely do not just sprinkle them everywhere. And this is so important. It's straight from the official React docs. These hooks are for optimization. They're meant to make your app faster, not to make it work in the first place. If you remove a useMemo and your code breaks, you don't have a performance problem, you have a bug. Go find that underlying issue and fix it first. All right, so we've spent a lot of time talking about what happens inside the app once it's running. Let's switch gears. Let's talk about getting the user into the app. That first impression, that initial page load is absolutely critical. We've got to make it as fast as humanly possible. You see, as your app gets bigger and better, so does its JavaScript bundle. And that massive bundle? It's like a giant traffic jam on the information superhighway. It seriously delays how quickly a user can actually click on things and interact with your site. This is a huge factor in your core web vitals, which, as you know, is what Google uses to judge user experience. So how do we clear this traffic jam? Well, React gives us a fantastic solution called code splitting, and we do it with React.lazy and suspense. This is an incredibly powerful combo. It lets you break up that giant bundle into smaller chunks so the user only has to download the code for the part of the app they're looking at right now. So what are the best places to use this? Think about the distinct parts of your app. Entire pages or routes are the perfect candidates. Or maybe those really heavy UI components, like a big charting library or rich text editor. Or what about areas that most users never even see, like your admin panel? If it's not needed on that very first load, it is a prime target for lazy load. Okay, we've just loaded up our toolkit with some seriously powerful stuff. But before you run off and start using it, we have to talk about the single most important golden rule of all performance engineering. This is how we move from just guessing to actually engineering a solution. The mantra is so simple. If you didn't measure it, don't optimize it. I'm going to say it again. If you can't measure the problem, don't try to optimize it. Just blindly sprinkling useMemo all over your code, it usually just leads to more complexity and code that's harder to read, all for basically zero real-world performance gain. So, these are your diagnostic tools. This is how you measure. You've got to start with the React DevTools profiler. It literally shows you which components rendered, why they rendered, and how long it took. For instant feedback while you're coding, the Why Did You Render library is just invaluable. And then for the ultimate ground truth, you've got the browser's own performance tab. Think of yourself as a performance detective, and these are your instruments. So I'm going to leave you with this one final question, a question you should ask yourself every single time you reach for one of these tools. Ask yourself, am I actually optimizing, or am I just adding complexity? If you approach performance with data, with real intent, you're going to build apps that aren't just packed with features, but are genuinely a delight to use. Thanks for joining me.